Today we're going to look at how to add and subtract fractions when the denominators are different. So here we see 6 and 12. You must have the same denominators in order to add and subtract fractions. So if they're not the same, as in this case with the 6 and 12, then there's a couple of steps that you have to do before you can actually add or subtract. So we're going to look at this problem first. And you see that we have 3/6 minus 4/12. So our very first step, since the denominators are different, we are going to do the big M and find out what our common denominator is. So when we have 6 and 12, we know we can go up to 12 from 6, 12, and then our LCD will become 12. So now that we have our least common denominator, we can make our equivalent fractions. So we take our original 3/6 and 4/12 and we're going to make them where both of the denominators are 12. Okay, so now that we've done that, now we have to figure out what this top one is going to represent. And the way that you can do that is by figuring out what you multiplied 6 in order to get to 12. Well, we know 6 times 2 equals 12, and whatever you do to the bottom, you must do to the top. So we say 3 times 2, which is 6. So now we have 6/12 instead of 3/6. So we're going to write that as our new fraction. Let's do the same thing with 4/12. Well, we know 12 stayed as 12, so therefore 4 needs to stay as 4 because it's 12 times 1 equals 12. 4 times 1 equals 4. Whatever I did to the bottom, I did the same thing to the top. So now my fraction is still 4/12. So now my new problem is 6/12 minus 4/12. But is it truly a new problem? No, because it's equivalent. So it's the same thing, but now our denominators match and we're able to subtract. So we say 6 minus 4, which is 2. And then we know that when we add and subtract fractions, our denominator never ever changes. So it stays 12 because that's representing the size of our pieces. So we're saying 6/12 minus 4/12 equals 2/12. The final step, you always have to ask yourselves, can I simplify? Well, 2/12, if we divide by 2 to the top and bottom, we would get 1/6. And that is our final answer. So let's do another one, but this time we're going to add. So we're looking at 3/7 plus 1/3. Uh-oh, what do we see? The denominators are different. So our first step is, you're right, the big M. So we have 7 and 3. 3, 6, 9, 12. Nothing so far. 12, 15, 18, 21. Stop there. We know that the only one that 7 has in common is 21, so that is our new denominator. So again, we take our original fractions and we find equivalent fractions of those. So let's take 3/7 first, and we know that now that we have our denominator of 21, we have to make this one also say 21. So 7 times what gives me 21? 3. 3 times 3 gives me 9. So our new fraction is 9/21. And then we do the same thing to 1/3. 1/3 has to have the denominator of 21. That's times 7 times 7. 7 times 1 is 7. So our new fraction is 7/21. Now we're able to add because our denominators are the same. So we have 9 plus 7, which is 16. And then 21 plus 21, no, we always leave our denominators the same. So it stays as 21 because that's saying the size of our piece. So now we look, 16/21. Can that be simplified? Well, we notice that 16 and 21, they're not both even. We know 21 is divisible by 3. Is 16? No. We know 21 is divisible by 7. Is it divisible by 16? No. So 16 out of 21 is simplified. So now let's look at the bottom two, but this time instead of doing our m, we are going to model it. So we have 12/15 and 3/5. We know that we can model 12/15 by drawing our 12/15. Actually, let's go to a new page. No. New page. No. New page. No. Nope. Okay, here we go. So we'll do 12/15 minus 12/15 minus 3/5. Okay, so again we notice that our denominators do not match. So we need to find a common denominator, and here we know that we could do 15ths. So we're only going to change this one because we know that 5 can go to 15 by multiplying times 3, which is 9. So now we're going to show 12/15 minus 9/15. So we have to model it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we have 15 there. Now we need to shade in our original 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But now that we notice that we are subtracting, that means we're going to have to take away 9. So let's go backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to leave us with 3. What's the size of our pieces? 15ths left over. And that's it.